Hey guys, welcome to the last play-by-play video number 49. We're left with the air intake and dash pieces and we'll be all done for this Kawasaki Ninja H2R. The final and last video will be coming up soon, and in there, we'll be tackling retopology and putting this whole project together. Bring up the gizmo. From the gear, let's choose Polycube this time. Weld it in the x-axis, then unmask the top and move it upwards. Mask the middle point and give it a slight lift. Unmask the bottom next and extrude it with the gizmo. You'll want to pull out the corners a bit. Once you've cleared the mask, use the slice curve brush to add in some edge loops. Let's turn on symmetry in the x-axis. Unmask the poly and give it a gizmo extrusion. For the next few moments, we're going to keep extruding, masking, and nudging points into place. So let's have a chat about the slice curve brush and the clip curve brush. The slice curve brush in ZBrush is a really remarkable tool. Imagine you're sculpting a complex mechanical piece or a robotic character with various components. This is where the slice curve brush shines. You can draw a line or even a more complex curve on your model. Once you've drawn the curve and completed the stroke, ZBrush does its magic, slicing the mesh along the drawn path. The power of this brush becomes apparent when you have to define distinct parts of your model or segment intricate mechanical details. But the tool doesn't stop there. It's more than just a slicing tool. When you make that cut, it doesn't just add in an edge loop. Instead, it cleverly assigns a new polygroup to that slice section. This makes manipulating and managing your model easier, especially when working with intricate mechanical components. You can isolate, hide, or work on individual polygroups, making your workflow more organized and efficient. You can also use it to help with edge flow for Z-remesher, add in edge loops, or used for guiding curves on the mesh. Using the slice curve brush can initially seem intimidating if you're unfamiliar with it. But once you understand its functionality, it becomes an invaluable part of your toolkit. Now that we've gotten to grips with the slice curve brush, let's shift gears and talk about another ZBrush star, the clip curve brush. Think of the clip curve brush as a magic wand that reshapes your mesh based on the curves you draw, making it a vital addition to your hard surface sculpting toolkit. Unlike the slice curve brush, which slices the mesh and creates a new polygroup, the clip curve brush pushes all the geometry along the drawn curve line, effectively flattening it. To visualize it, imagine you're working on a robot's armor and you want one side to have a flat, planar surface. You'd select the clip curve brush, draw your line, and ZBrush would instantly push the geometry along the line, creating the flat surface. It's as if you're shearing off the excess to create the hard, planar surfaces that hard surface models are known for. But here's where it gets interesting. If you draw a curved line, the clip curve brush would still push the geometry along the curve, effectively giving you a rounded, flat surface. This ability to create both flat and rounded planar surfaces is why the clip curve brush is such a versatile tool. It allows you to have an immense amount of control over the shape and form of your models. The good news is you can use the clip curve brush with symmetry activated. This lets you make the same changes on both sides of your model, ensuring consistency and saving you some precious time. But remember, the clip curve brush, despite being a powerful ally, doesn't add or subtract geometry. It simply rearranges the existing polygons, which could sometimes result in complex geometry or stretch polygons, depending on your clip curve complexity. So you might need to roll up your sleeves and do some cleanup afterwards, which usually just consists of dynameshing after each clip. In the grand scheme of things, while the slice curve brush and the clip curve brush offer different functionalities, they're a dynamic duo, making your hard surface sculpting experience more efficient and versatile. Alright, let's dive back into the play-by-play. First off, unmask the edges and give them a quick cleanup with Polish by Features to smooth out the curve. Then add in an edge loop. Nudge the points a little better to mirror the reference. Alt-click the top polys and Q-mesh them up. Then unmask the polys and clean them up with the Polish by Features. Slide the edges back a bit to tweak the slope. Press Ctrl W to group visible. For the polygon action, we're going to select Polygroup, and for the target, let's go with Facing Front Island. Select the top polygroup and hit Delete Hidden. Then we can delete half the model. Mask the middle polys and give it a 45-degree twist. Alt-click these polys to transpose. Move it down and position it using the gizmo. Clear the mask and adjust the shape by sliding the edges and points. Go ahead and unmask the edges to straighten them out. Next, we want to add in an edge loop. Alt-click the two polys to transpose them down. Mask the border edges and tweak the edge loop. Tag the polys to Q-mesh up. Then we can delete the bottom faces. Next, slide the edges to modify the shape. Then we can collapse the inner vertical edges. Switch to the Move Point action to adjust the slope. From here, we're going to keep extruding out more geo and nudging them into place. Then we'll mirror and weld and extrude all polygons. Finally, we'll punch in the screw holes. There'll be quite a bit of tedious point movement that I don't think you need to see at this stage. The key thing is getting the block out right. Bring up the gizmo and select Polycube from the gear. Mask out the points and move them into position. Slice in an edge loop, Then for the edge action, select Move Infinite Radius, and for the target, go with Edge Loop Complete. Press Ctrl W to group visible. Then we can grab the Move Infinite Depth brush. Unmask the poly and extrude it with the gizmo. Mask out the edges and move them into place. Then we can slice in edge loops and reposition them using the Move Infinite Depth brush. It doesn't have to be perfect right now, we'll clean it up soon. Press Ctrl W to group visible. Press Group by Normals and give it a Polish by Features. Unmask the poly and extrude it using the gizmo. Mask out the edges and move them into position. Then we can make some minor tweaks using the Move Infinite Depth brush. Next, grab the Move brush to nudge individual points. Then we can add in an edge loop. Then finally use the Move Infinite Depth brush to modify the shape. Okay, let's get started by alt-clicking to remove the polys. Then select Bevel Edge Loop Complete. We want to slide the points over to keep the bevel consistent. Next, select Insert Multiple Edge Loops with Interactive Elevation. Let's repeat this action on the other bevels. Choose Extrude All Polygons and then hit the Flip button. Enable dynamic and then press crease PG. Set the smooth subdivision to 4 and the crease level to 3. Now it's time to add in some support loops. For our last piece, the supercharger's gasket, we'll use the gizmo. Select Cylinder 3D from the gear. Set the H divides to 24 and the inner radius to 0.7. Press QC50. Then scale the cylinder on the Z-axis. For the polygon action, select Bridge. For the target, choose Connected Polys and Circle. For the modifiers, go with Interactive Curvature, Interactive Resolution, and Triangle Sides. Enable symmetry on the X-axis and unmask the faces. Scale it on the X and Y axes. Uncrease the edges and press Ctrl W to group visible. Set the crease level to 3, and then Q-mesh the poly loops. Slide the edge loops to create the bevels. And this is what we have so far. There's the gasket and the air intake. Like with the foot pegs, anything super simple like the cylinders, I won't bother showing you at this stage. Here's another piece that's just a cube. Everything else is what we've been modeling in the past few videos. I've hidden the Boolean treads on the tires for now, but we still have to create the text for the tires, model the wires, and place in the fasteners.